In this video, we're going to be adding and subtracting radicals. So they give us definitions of like terms. Two variable terms are said to be like terms if they have the same base and corresponding exponents. And two radical terms are said to be like radicals if they have the same radicand and the same index. In one, they want us to add or subtract as indicated. Assume the variables represent positive real numbers. In A, we have 4x to the 1/2 plus 7x to the 1/2 minus x to the 1/2. And all of these are going to be like terms because the base is the same, x, and the exponent is the same, 1/2. So we're going to add 4 plus 7 minus 1, which is equal to 10, x to the 1/2. And then we have 4 square root of x plus 7 square root of x minus the square root of x. And these are going to be like radicals because they have the same radicand, which is x, and they have the same index, which is 2. So we're going to have 4 plus 7 minus 1 is equal to 10 square root of x. In B, we have 4 times the cube root of AB plus 7 times the cube root of AB minus 1 cube root of AB. And we have like radicals. The index is 3 and the radicand is AB. So we have 4 plus 7 is 11 minus 1 is 10 times the cube root of AB. In this next one, we have 4 times the cube root of AB plus 7 times the cube root of AB minus the square root of AB. Now here, only the first two terms are like. And the last term does not have the same index because it's 2, where the other indexes are 3. So we can only add the first two terms together. So we have 4 plus 7 is 11 times the cube root of AB minus the square root of AB. In C, we have 5xy plus 3xy. And these are like terms because we have xy as the base and 1 as the exponents for both terms. So we have 5 plus 3 is 8xy. In the next problem, we have 5x times the square root of y plus 3x times the square root of y. And here they're both like terms. We have x to the first power in both terms and the square root of y in both terms. So we have 5 plus 3 is equal to 8x times the square root of y. And 2, it wants us to add or subtract as indicated. Assume the variables represent positive real numbers. So we have 2 times the square root of 63 minus 11 times the square root of 28 plus 2 times the square root of 7. And we want to simplify each term. So for the first term, 2 times the square root of 63, we could write that as 2 times the square root of 9 times 7 minus 11 times the square root of 4 times 7 plus 2 square root 7. So now the first term, we can take the square root of 9, which is 3, and 3 times 2 is 6 times the square root of 7 minus the square root of 4 is 2. 2 times 11 is 22 times the square root of 7 plus 2 times the square root of 7. And now we have like radicands and the indexes are all the same. They're all 2. So we have 6 minus 22 is negative 16 plus 2 is negative 14. So we have negative 14 square root 7. In B, we have the square root of 50 x squared y to the fifth minus 13y times the square root of 2x squared y cubed plus x times y times the square root of 98y cubed. So we want to simplify each term. So we can rewrite the first term as the square root of 25 times 2 x squared y to the fifth minus 13y square root of 2x squared y cubed plus xy times the square root of 49 times 2 y cubed. And now we want to take all the perfect squares out of the radical. So we have the square root of 25 is 5, square root of x squared is x, and the square root of y to the fifth is y squared square root of y. So inside the radical we have 2 and we have a y minus, now we have 2 is not a perfect square, so we're not going to take 2 out, and we have x squared, so we're going to have an x outside of the radical, so we have 13x. The square root of y cubed is y square root of y, so we're going to have one y coming out of the radical and times the other y, so y squared times the square root of 2y plus the square root of 49 is 7. We had an x on the outside already, this x, and now we have the square root of y cubed is y square root of y, so we're going to have y times y, or y squared on the outside, times the square root of 2y. And now we want to combine like terms. And all of our terms here are like. We have the same base with the same exponent in each term, and the same radicand and the same indice in each of them. So we're going to have 5 minus 13 is negative 8, plus 7 is negative 1, so we have negative x y squared times the square root of 2y. In C, we have 3 halves ab times the square root of 24a cubed plus 4 thirds times the square root of 54 a to the fifth b squared minus a squared b times the square root of 150a. So we want to simplify each term. So we have 3 halves ab times the square root of 4 times 6 a cubed plus 4 thirds times the square root of 9 times 6 a to the fifth b squared minus a squared b times the square root of 25 times 6a. And now we're going to take all the perfect squares out of the radicals. So we're going to have the square root of 4 is 2. 2 times 3 halves is 3. And we have the square root of a cubed is a square root of a. So we have 2 a's on the outside now, a squared. And then we have b times the square root of 6a plus we have the square root of 9, which is 3. 3 times 4 thirds is 4. The square root of a to the fifth is a squared square root a. And the square root of b squared is b. So we have times the square root of 6a minus the square root of 25 is 5. So we have 5. And the other two factors inside the radical are not perfect squares, so they're going to stay in there. So we have 5a squared b times the square root of 6a. And all our terms are like, so we're going to add 3 plus 4 is 7, minus 5 is 2, a squared b times the square root of 6a. And that's our video on adding and subtracting radicals.